A uniform electric field has a magnitude of 2.6 times 10 to the third newtons per coulomb. In a vacuum, a proton begins with a speed of 2.49 times 10 to the fourth meters per second and moves in the direction of the field. Find the speed of the proton after it has moved a distance of 2.02 millimeters. So for this problem, we are going to use the work energy theorem, which states that work is equal to the charge, which is Q, times the magnitude of the electric field, which is E, times the distance. And this also equals the distance times the kinetic energy. And we know that kinetic energy is equal to 1/2 mv squared. But in this case, since we have a initial velocity and a final velocity, we are going to modify this a little and then set it equal to QED. So the equation that we will be using is QED is equal to 1/2 mv final squared minus v initial squared. So this is a combination of the work energy theorem and the formula for the kinetic energy. And now we are going to solve this equation so that we can separate v final, so that we just have a clear straight cut path and we can just plug in everything and find the final velocity. So for this, we're going to multiply both sides by 2 to get rid of this 1/2, and then divide both sides by m, so we get 2QED over m is equal to v squared minus v naught squared, and then we're going to add v naught squared over to this side and then take the square root of both of the sides so that we get a clear formula for v final. So v final is equal to the square root of 2QED over m plus v naught squared. And now we can just plug in all of our numbers here. So 2 times the charge of the proton that the question is talking about, and we know that the charge of a proton is 1.602 times 10 to the negative 19th coulombs, times E, which is the magnitude of the electric field, and the problem gave us 2.60 times 10 to the third newtons per coulomb, and then we have the distance. And notice how this distance is given to us in millimeters. We are going to convert that into meters. So 2.02 millimeters is equal to 0.00202 meters. And now we are going to set that over the mass, and we know that the mass of a proton is 1.6726 times 10 to the negative 27th. And remember, this has to be in kilograms or else this won't work. And then we have to remember this v naught initial squared, and I've run out of space here, but it's still going to be under the square root, so I don't know how to write this. I'll just write plus the square root of the initial velocity squared, and the initial velocity is 2.49 times 10 to the fourth meters per second squared. So we're just going to put all of that into the calculator, and when we put all of that into the calculator, what we get is 40,324.59 meters per second as the final velocity, or 4.03 times 10 to the fourth meters per second, and that is the final velocity of the proton after it has moved that distance.